Okay, good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, our lesson today, we will be looking at information on hotspots. We have covered extrusive activities, and for the work on extrusive activities to do with volcanicity, we have looked at volcanoes. And we have identified the different or the three main structures that most volcanoes can actually be classified under, and they are the shield, the composite, and the ash and cinder type structure. We have also looked at different types of eruption that can occur when volcanoes erupt, and we also looked at different types of materials which are emitted during a volcanic eruption. As well as that, while we are on volcanicity and looking at volcanoes, today I'd like us to actually touch on that information on hotspots. So for our lesson today, we will basically look at the definition to what a hotspot is, and then we will look at an example of a country and volcanoes which are found using or not using, but which are found over an area of hotspot. But before we go on to the information on hotspots, what I'd like us to do now is to correct the exercise that we were supposed to have completed for homework, and that was looking at volcanoes in Papua New Guinea and then identifying the province that those volcanoes were in. We looked at active volcanoes in the country, and we also looked at the dormant volcanoes in Papua New Guinea. Your task was simply using an atlas to find out the province of which those volcanoes are located in. And another part of the homework was also to look at a paragraph, for you to write a paragraph describing the distribution of volcanoes in Papua New Guinea. Let's look at those two activities. We'll start off with the first information. Okay, with the dormant volcanoes now, and you can make corrections to the work. The Bloop Bloop volcano in Papua New Guinea, it is found in East Sepik. Cadaver, that's the next volcano that is also found in East Sepik. You correct your activities. Talo, that's the volcano found on Siasi Island, and that is Morobe province. That's the Talo volcano. Garove, Makalia, Gabuna, Galoseulo, and Bamus are all found in West New Britain province. Okay, Balbi and Loloru in the North Solomons province. Okay, we have Kururi and Victory are found in Oro province. Wagipa, Lamonai, Oyo, Dobu are found in the Million Bay province. Doma Peaks in Southern Highlands, in the Southern Highlands province, and Yelia in the Eastern Highlands province. Okay, those are the information for the dormant volcanoes in Papua New Guinea. Did we leave out or did I miss out any? You check. Okay, then we look at the active volcanoes in Papua New Guinea. Rabaul, that's East New Britain. Leamington, Oro, Manam, Karkar in Medang. Langila, West New Britain. Bagana in the North Solomons province. Pago, West New Britain. Long Island, Medang. Rita Island, Morobe. Lolobau in West New Britain province. Goropu in Oro province. Bam in East Sepik province, and Tuluman in Manus. Okay, those are the active volcanoes in the country and the provinces they are supposed to be located in, and that is what you were supposed to also complete for your homework. Did I miss out any of the other volcanoes and you have made note of? Yes. Ulawun, okay, an active volcano. Ulawun in which province? It will have to be in the West New Britain province, okay? Ulawun in the West New Britain province. Any others? Okay, if there are no other volcanoes, then we check. The information that we have looked at doesn't mean that those are the only volcanoes we have in the country, but those are some of the dormant and they are some of the active volcanoes we have in the country. There might be some that we have left out. Say, for example, if we looked at the Rabaul volcano, there's a couple of volcanoes in Rabaul, but we have just generalized and we have put all of them under the heading on Rabaul volcano. Okay, that brings us to the end of that activity, and that is work on volcanoes in Papua New Guinea. What I would like us to actually move on to now is looking at the information on hotspots. You should have a handout, and on that handout will contain the information which I will also go through on the monitor. Okay, hotspots. The definition, first of all, to what hotspots are. Hotspots are localities on the Earth's surface where greater than average thermal activity takes place, often leading to volcanic outbursts. Hotspots are thought to be the crustal expression of plumes in the underlying mantle and are believed to be closely related to the mechanism of plate tectonics. So here we have a definition of what hotspots are. They're looking at localities on the Earth's surface where greater than average thermal activity takes place, often leading to a volcanic outburst. From the definition, you will also see one of the words which is mentioned there, and that is mantle plume. What are we referring to when we are referring to plume in that particular definition? Mantle plume is a term describing the mechanism in which rocks in the Earth's mantle begin to melt, thus becoming less dense and therefore rising towards the surface as the vertical component of a thermal convection current. From what we have already studied about convection currents, we would have seen that material from under the surface is actually forced to rise up towards the surface. And that cycle contributes also to tectonic plate movements. It tells us that this is thought that convection current actually rising towards the surface is thought to cause doming and then finally rupturing of the crust at certain points. And where there is the rupture at certain points, that's where we tend to have formation of volcanoes or basaltic plateaus created. But usually in areas around the world where there are hotspots, there tend to be cases of volcanoes being evident or volcanoes formed in those areas where there is a hotspot. If we look at a diagram to show the information on mantle plume, we have the continent here. The information here is supposed to show cracks or fissures of which will allow the magma from under the surface to flow out onto the surface. And the black area here on the diagram represents a flood basalt. And that flood basalt is simply formed, it's an extrusive feature which is simply formed as a result of magma coming out onto the surface and solidifying. But note, not all the time will there be a flood basalt which is created as a result of the uprising of the mantle plume together with the convection currents or with the aid of convection currents. What might be created on the surface can also be a cone. And when a cone is actually created, then we have a volcano. The diagram here shows the mantle plume, which rise upward through the mantle. When the large head contacts a continent, it causes uplift, as in this case here, the uplift, resulting in a dome being created and the eruption of flood basalt, especially out on the surface. So you see the head of that mantle plume, it starts off here, it is actually carried up towards the surface through the process of convection currents. When the head reaches the continent, what might happen then is a doming is created, and also where there are cracks or fissures, the magma flows out onto the surface then as basalt solidifying or a volcano being formed. So with that information, we note, as well as the volcanoes which lie or which line the edge of plates, or from what we have covered already on tectonic plate movements, we did mention that volcanoes can also tell us, or volcanoes can also mark plate boundaries. Like in the case of the Pacific plate, if we wanted to find out where the plate boundary was, we could only look at the chain of volcanoes right around the Pacific plate to be able to identify the Pacific plate boundary. But not all volcanoes are actually found on plate boundaries. There are some cases whereby volcanoes can be found in the middle of tectonic plates. Their explanation can be owed to the information on hotspots. And that's what we are looking at in our lesson today. Let's check the next information and then we will move on to the activities that I'd like you to work on. As well as the volcanoes which line the edge of plates, tectonic plates we're referring to here, some volcanoes are found away from the plate boundaries. These volcanoes are thought to have formed from mantle hotspots from deep in the earth, which melt the plate above, forming a volcano. These volcanoes are normally basaltic in composition, but can include more silica-rich material over time. It is in these hotspot locations that the best shield volcanoes are actually developed. Let's look at the example of the country Hawaii. And before we look at the information presented on that particular example, let's look at a map of the world showing us examples of volcanoes of which can be identified as volcanoes created or formed due to the fact that there are hotspots in the Earth's crust or in the mantle, allowing for the formation of those volcanoes. Okay, we check the tectonic boundaries. Say, for example, the Pacific plate. We know already from what we have studied that the Pacific plate is actually marked by Pacific ring of fire or a line of volcanoes. In the case of Hawaii, see the location of Hawaii here. It is right in the middle of the Pacific plate. So it is not on the edge for us to say that it is to do with being at the plate boundary which has created the formation of the volcanoes. Rather, Hawaii, the country here with its volcanoes, it's in the middle of the Pacific plate. The explanation of how this is possible, we owe it to hotspots. Okay, and the dots, the red dots on this particular map here generally shows us some of the volcanoes around the world which are known as hotspot volcanoes. You have that information also on your maps on that worksheet that has been distributed. Okay, we'll concentrate on the example on Hawaii. Okay, if we look at the information on Hawaii, it tells us there that Hawaiian Islands are a chain of volcanic islands formed. They were formed where the Pacific plate is moving across a hot spot. One of the things that we need to remember on hotspots is that hotspots are usually stationary. But plates, when they are moving, will move over the hotspot. And upon the movement of the plates over the hotspot, if there is a weak area whereby magma can be forced to rise up, then a volcano is actually created. Given time, we're looking at geological time here. Given time, with the continuous movement of plate, that volcano which was once active will become extinct as it moves away with the plate that is carrying it away from that hotspot. And then a next volcano might come over, or another, while the plate is moving, a weaker area again might come over the hotspot, resulting in the creation of another volcano, and etc. So the hotspot is usually stationary. Plate movement will actually carry the crust over the hotspot, and where there are weak spots, we can have volcanoes being formed or created. So we look at the example given there. It says there that the movement of the plate can be seen as the volcanoes in the chain or the island chains in Hawaii become older as you move northwards. Okay, if you check this diagram here, this is where the hotspot is. At this point in time, this volcano is active because it is right above the hotspot. The direction in which this particular plate has moved is in that direction. According to the information here, it will be towards the east or west. From where you are sitting, looking at that information, it will be to the west. Okay, so here, this particular plate is actually moving to the west. Meantime, there is a hotspot here. While the plate is moving, you will note that once upon a time, this particular mound would have been over the hotspot, but now it has become extinct. Similarly, once upon a time, this particular mound or peak here could have been over the hotspot, and etc. In other words, as we move towards the west, according to the diagram here, the volcanoes, or you would tend to find that the volcanoes are, in terms of the rocks found there, are older compared to those that are closer to where the hotspot is. Okay, let's do some activities. We're going to work on some activities now. You have a map of Hawaii, the country Hawaii. Not all of the islands of Hawaii is actually shown here, but this example will show us that definitely Hawaii has a chain of volcanic islands. The main area here, of which we have studied about Mauna Loa. Mauna Loa is a shield volcano which is found in Hawaii. It is located on this particular island. Okay, what I'd like you to do now is, using this map and using your map on plate tectonics, I'd like you to answer the following questions. Number one, on which tectonic plate does the Hawaiian Islands sit? Number two, in which direction is that particular plate moving in? And number three, you refer to the country of Hawaii and those islands, and you make a list of those islands which contain the oldest, or which will contain the oldest volcanic rock, to the islands which will contain the most active or the latest volcanic rocks. Okay, you can work in pairs for your answers, and I'll give you about 7 minutes for the completion of that work, and we'll correct the exercises together. Those activities.
That's good. Okay, the next thing I'd like you to do now is we're going to make a list of all the examples. Give us some examples of hotspot volcanoes around the world. And not only that, because it's a new concept, you might want to also make the write the definition so that you get to understand it a little bit better.
Okay, I think most students have finished. So we will check on those activities now. Val, you're going to give us the first answer to that question, and then followed by Kathy as we move along in that row for our answers. Okay, the first question reads, on which tectonic plate does the Hawaiian Islands sit? I think that is easy and straightforward. Val, your answer?
The Hawaii plate sits on the Pacific plate.
Okay, the Pacific plate. Okay, the rest we check. The Hawaiian plate? No, the Hawaiian Islands sit on the Pacific plate. Okay, thank you, Val. We move on. The second question. So answer is the Pacific plate. The second question. In which direction is that particular plate moving, Kathy?
The plate is moving in a northwesterly direction.
Okay, very good. So if we look at the information on the monitor, the direction of the movement that's for the Pacific plate is in a northwesterly direction. So northwest. Check and make corrections to that particular question for anyone who's got it wrong. The next question, your answer, you're going to now list the islands which contain the oldest volcanic rock to the islands which contain the most active volcanic rock.
The first island is Kauai.
Okay, when you say the first island, what are you referring to? The first island as in active or the oldest?
Oldest volcanic rock.
Okay, good. So we start with Kauai.
The second is Oahu.
Correct.
The third, Molokai. The fourth, Maui. And fifth is Hawaii.
Okay, good. So if we can double check with that information in that order from the northwest down to the southeast. In other words, we can see here that the hotspot is actually found where the Hawaiian main island is today. And because of the direction of that movement in the southeasterly direction, the plate movement moving to the southeast direction, the Pacific plate I'm referring to here, then these particular areas, once upon a time, they were over the hotspot. But because of the direction in which the plate has moved, they are now away from the hotspot. And this group of island here has or is now sitting right over the hotspot. And as a result of that, we have volcanoes such as Mauna Loa, which is also formed from a hotspot. If we had to look at information which has been collated and put together on the age of volcanic rocks to prove that yes, if we looked at the direction from the oldest to the latest, then evidence which has been already collected by scientists can show us that on this island, the rocks generally, the volcanic rocks generally would be about 3.8 to 5.6 million years old. Then as we move closer to the Hawaiian main island here, we come to this part of the island with 2.7 to 3.4 million years old, the age of the volcanic rocks. On that side of the island, but towards the eastern part of this island here, 2.2 to 2.5 million years. We come to this particular island, the western end of the island, 1.8 million years, that's for the age of the rocks. The eastern end of Molokai Island, 1.3 to 1.5 million years, the age of the rocks. Then we come to this island here, 1.2 to 1.3 on the western end, on the eastern end about 0.8 million years. And finally, on this main island here, we have rocks which are as new as being released from the eruptions when it or while it is taking place to about 1 million years old. Okay, to finish off and to sum up our lesson, I'd like someone in the class to actually explain in their own words what you know now about what a hotspot is. What is a hotspot, or what have you understood about the definition or the meaning to what a hotspot is? Someone like to give us an explanation from what they have understood on what we have covered? Susan? Okay, Susan is going to tell us from what she has learned, definition to what a hotspot is.
Well, to summarize everything that you taught us, I know now that hotspots stay where they are and plates move above the hotspots. That's how volcanoes in between the boundaries are formed, because the hotspots, the mantle beneath the hotspots form a volcano, and as the plate drifts, that's how we know in which direction the plates move. We know how old the islands are, volcanoes, yeah.
Okay, maybe you're getting the idea, definitely. We're looking at one important point. She's mentioned the hotspots, they remain stationary. The plates move over the hotspots. And when the plates move over the hotspots, where there are weak areas in the crust, volcanoes are formed. Anyone else would like to tell us what you have learned so far from our lesson today? The definition to what you think hotspots are? I'm trying to see whether you have understood the information we have covered or not. Gideon, would you like to tell us what you have learned from the information on hotspots?
Hotspots, volcanoes can be created or formed on hotspots as a result of plate movement, and where there is a weak area on the crust, the mantle is forced up, and in doing so, volcanoes are created.
Okay. Good explanation there. We note usually where the magma rises up onto the surface from where the hotspots are, volcanoes can actually be created. Anyone else like to tell us what they have learned already from the definition to what hotspots are? Gibes, thank you. We'll finish off with the information from Gibes.
Hotspots, it's a spot where the where a convectional current is taking place, where magma is pushed out to the surface, and it's stationary there, and only the continental plates move, but the hotspot stays where it is, forming volcanoes.
Okay. Again, we need to be able to say that when the continents, or not the continents, but the plates, when they are moving over the hotspots, what would usually happen is that if they come across an area where the mantle plume is, it rises up to the surface, resulting then in the outburst of magma, which then creates a hotspot. The other thing you need to remember is that the hotspots are not found in areas where there are tectonic plate boundaries. Rather, they are found in the interior or further away from plate boundaries. And when we see volcanoes of such, then we can say we can owe the explanation to hotspots. That will also conclude our lesson for today. Class, if you can now stand up. To the pilot teachers, our key word for lesson 41 is mantle plume. Good afternoon and thank you, class.